Hey, so getting started with the assembly demo, what we're going to do is we're going to start by opening the top level assembly, which is ASM01, 4 zeros and a 1. We want to make sure that these are all unchecked and you do a save as default. This way when you open this, the components that we've set to be active will be active, and same thing for the components that we've set to be inactive. The intention of this demo is going to be to show some of the functionality that assembly modeling has brought to the user with ST2. The concept that we want to show is the ability to assemble components against a 2D sketch that contains intelligence. The components will be constrained to the sketch, so we can come back later, make changes to the sketch, and have the assembly model update as we complete the model, check for interferences, and continue with our work. The mower deck that we're going to make a change on, as you can see, there's a complete mower deck that's visible. There's another mower deck, ASM01 00700, whose visibility is turned off. We're going to open that so that it comes into another window, and you can see some of the components are here. So we'll just quickly go over to configurations, and we're going to change to the assembly start configuration. This suppresses all components so we can see only the sketch. The sketch is our layout. There's 3 different diameters set up to show the diameters of each of the mower blades, a dimension to control the width of cut, clearance, and a representation for the belt. We're going to start kind of partially started with a couple of the components already constrained. So I'll change to another configuration, and I want to go to the parts library, and you want to make sure that in the parts library, here's the directory that I've delivered the Iron Eagle data set, and there's a subfolder called assembly. We can grab all of our components from here. We're going to grab this 00601, drag and drop this into our assembly, and I've already captured fit, so I can just grab this circle, and then I'm going to use a planar align, grab the top face of our assembly and line that up with the top face of an existing one. I'm not too concerned with rotation at this point, so I'm satisfied with that component. Next, I'm going to go find the ASM02 00037. Drop this into our model, and here again, I'll use my capture fit constraints. I'll grab to this circle, and then it's going to pivot against this location, and then align it to the top face here. So these are my main mechanisms for the mower deck assembly, and you can see that things aren't quite where I want them to be. This was conceptualized at 1,222 millimeter for a width of cut, but marketing is telling me that I need to change this model from this size to 1,122 millimeter. So I will select that dimension and change it. You can see that everything has shifted accordingly. With this narrower width of cut, I can now use a smaller blade. So I'm going to go from a 500 millimeter blade to a 430 millimeter blade. And here again, all of my sketch relationships are maintained as it drives the sketch, which in turn drives all the components inside of my assembly that I've built thus far. Now, the next thing I want to change is, after I've changed this, my belt is who knows what size. I need to specify a belt size. I'm going to take advantage of, under the inspection tool, and use goal seek. I've already created this as a boundary, so I've changed the length of the boundary to belt length. It tells me the current size, and I'm going to specify this to be 2,650 millimeter, and I'm going to achieve this by modifying a dimension, tension, or angle. I'll hit accept, and you can see the tension or angle is being driven until I've achieved that perimeter. And here you can talk about the power of goal seek. And what I'm doing is I'm holding my 3D mouse so that as soon as the goal seek is done, it's fine tuning into that size. As soon as it is done, I'll see the model start to rotate. So now my layout is correct and my assembly is where I would like it to be. So I'm going to change now to the select command, and I'm going to go back to the Pathfinder. If I scroll to the bottom of the Pathfinder, you're going to find a part, PAR02-00605. We double click that to in-place activate it. Then I'm now working in a part that already has a sketch. I've already copied in the outer profile and a profile for my belt. So I can come over and in place, do an add, sweep. I'm going to sweep about that path and sweep that profile. Hit finish. And you can talk about the benefit of taking assembly sketch information and being able to pass that to assembly parts. So now I'm going to close and return back into my assembly and go to the top level, and I'm going to simply right click the top of the assembly, do a show all, which will bring all of my parts, and then I'm going to hide the sketch so I have a little bit cleaner of a view. Now unfortunately one of the later builds has introduced a bug which has caused me to, there's a spacer here and there's two bushings inside of it, and the synchronous edit has a problem that it won't work when it ships on the initial release. That PR will be fixed on SP1. In the meantime, I've had to set these three parts as being non-selectable. The next part of the demo would be to go to inspect and do a check interference between this part and the belt. But with that being non-selectable, you won't be able to do that. So in the meantime, what you'll want to do in the demo is zoom in and show the user that there is an interference between these two pieces, and this occurred because of the change in the belt size. Okay, so next I will do a synchronous edit to fix this interference. So I'm going to go to close to a top view here, and I'm going to change my selection to face priority, and I'll do a window selection across these parts. And I'll come back to a view right about here. Now there's a couple of things that I like about this view. First of all, I want to see that I've got these rounded edges on here, these circular details in here. I'm also picking up a couple of circular faces on this stiffener plate and the sheet metal plate down here. Let's go ahead and take advantage of this opportunity to suspend the live rules because they won't be necessary. And I'm going to grab the origin and reattach it to this edge. My synchronous edit will be across the secondary axes, and I'm going to move it down here to someplace where it's not interfering. From this location I can pick whatever distance I want it to be, so let's just say 45 millimeter, and hit return. I'm really only stretching these two parts and the features in these two here. The assembly constraints now update for me automatically. And I can clearly see that I've given myself plenty of room so I don't have an interference while putting in a precise value. So my assembly is now put together and it's ready to go. So the next step will be I'll do a quick save on this. And I'm going to go ahead and create a drawing view. When you create the drawing view, there is a More Deck Quick Sheet. We do not want to run the View Creation Wizard. And this is going through and creating all of my preset views for me. And you can see our mower deck comes up with a shaded view. All of our balloons are displayed. Our bill of material comes up. Got a detail view that's already been predefined inside of the quick sheet and shows up, as well as my top view. And for the top view, what I'd like to do is just a couple quick dimensions. The point here is that you don't want to get caught up into a lot of detail. This is really an assembly demo as opposed to a part detailing drawing, but I do want to be able to capture some specific information and show that this can be done very quickly and very easily at the assembly level, as you've seen on some of the other demos for the part details. So now I've created this type of a drawing to represent the assembly. Another part that I put into here is that I've got a second sheet that I've added, and sheet 2, what it is just an exploded view of one of the blade assembly units, has balloons, and it also has a bill of material. And this is not an associative drawing. This is already set up inside of the quick sheet. But the benefit that you want to discuss when you show this to the customer is that the assemblies are not just to show the relationship of the assemblies put together, but it also provides, Solid Edge provides many powerful tools to be able to document your assemblies and components in different ways, such as maintenance drawings or assembly instructions, etc. And that includes the assembly demo. Thank you, and good luck.